Hello, welcome and good evening to another episode of Let's Code MS-DOS. Today we want to start tackling our most complex topic, programming the SoundBlaster sound card. Because, let's face it, I built so many sound cards over the last 2 years, the Snarkbarker, the Labs Blaster board, the Adlib clone, the MUS 1099, the Tandy card, that finally we want to do some sound programming actually. And this will take probably 3 episodes only for the SoundBlaster part for playing digitized sounds. This alone should show that this is a rather complex topic. In this first part we will just read and take a look at how to detect the SoundBlaster card and not even try to initialize it or play anything. In the second part we will set up everything for playing, set up the DMA buffers, the memory regions, install the interrupt handler and all that kind of stuff. But that will not even be enough. In the third part we will finally write a function to actually play everything and to read in all the data from a WAV file. So I could put this into probably one episode, but that would take at least 1.5 hours. So I'd rather make 3 separate 20 to 30 minute episodes which are easier to follow and where we have specific steps that we take. And I also will need to explain a bit more, draw some diagrams in the second part, but this start is actually pretty easy. You know all the basics from the VGA and keyboard programming. You don't need anything new here. And what I found here on the web is the SoundBlaster series hardware programming guide, which is actually pretty nice. I will link to it in the description, and I myself took a sample program from another website that I link to, which you can check out, but you can also just wait for us to cover everything. And I took this, reformatted it a bit, made it more in style with our programming stuff and broke it down into 3 separate pieces so that you can actually learn bits at a time. But enough of the talking, let's get started and let's try to detect a SoundBlaster card. Okay, so we need a bunch of includes obviously, and I'll just put them here so they're out of the way. We need the DOS header for all the interrupt handling and input and output on the ports. We need standard I/O for printing some stuff, and we also need some malloc stuff, which is in standard lib and in mem.h. Then we put some forward declarations here so we can call all the functions where we want. So our goal is to have a detect function which will detect if a SoundBlaster is actually in the system and which will return true or false. Then today we want to do the initialization routine and the deinitialization routine. These are the functions that will be called by any user of the program or of the code, and that's basically it. The detect function is supposed to find out which base address the SoundBlaster lives at. This could be the default 220 address. Then we also need to store which IRQ and which DMA channel the SoundBlaster is on. For example, for DOSBox this will default to IRQ7, although I configure my cards to IRQ5 usually, and DMA is in 99% of the cases channel 1. Also, we will already register an interrupt handler. We will call it we don't need to, we do need to register an interrupt handler, but especially we need to store the old interrupt handler if there was any. Usually it will be a default handler from the BIOS. And we store it in the variable called old IRQ. So the syntax here is void and then a hint for the compiler that this is an interrupt handler. This is absolutely pure DOS C, and you won't find this in modern C functions usually. And this is the syntax for a function pointer. So we have a pointer to a function, and the name of the pointer is old IRQ, so we can reference it via this. Alright, the other part we will fill in later. Then we will also need the implementation of the detect function, and this will look like follows. So at first we will say, well, we didn't find anything yet, and then we will iterate over a temporary or preliminary base address from 1 to 8, so less than 9, or could also write less or equal 8, increment, and if we are, and exactly, so possible values are 200, let's write that here. Possible values are 210, 220, 230, 240, 250, 260, not 270, but 280. So we need to exclude 270. There could be a different device. So if we're not testing 270, then we will do a reset of the DSP, and we will write that function very shortly. Add address 0x220, 200, plus either we can write temp times 16 because we're in hex, or we simply say left shift by 4. And I'm not sure about the order of operators, but we probably should do it like this. So that looks good. If we found something, we can break the for loop here, and we need to define temp, of course. That's that. And if temp equals 9, that means we have tested everything and didn't find anything. So we can simply say return false. But if we found something, we will find out which IRQ and DMA. There are ways to detect that as well. However, we will use the blast environment variable. So we need a string here, which we call blaster, because that's the name of the variable in the environment. And I can show you, if I type set, you will see the blaster variable there, right? It's A220 I7D1. Actually, we could have taken the port from the A variable part, but it's nice to actually check if it's there and then just take the interrupt and the DMA channel from there. So you can get the environment variable by calling getenv with the name of the variable, getenv blaster. And again, we will pretend that we did not find anything for the DMA, and then iterate over all possible characters in the blast environment variable. This should be probably something like string length. And if we encounter blaster at position temp, and well, we could write something like this, but people could also use the lowercase d, so we can write it with an or and do the same comparison again. Or some very nice trick actually is to bitwise OR with 32, which works in the ASCII character set just fine. And this is not my idea, this is from the example Blaster programming code. But I do like that this trick actually works. This basically ignores the high bit at position 5, because that's the only difference between D and D. So, if we find the D, then we know the next character must be the DMA channel. And here comes the trick that I do actually know, because the next character minus ASCII 0 will give us the numeric value of the number. This is a very old trick, and I've used that quite a lot. So this will give us 0, 1 or 3, depending on if you typed 0, 1 or 3 in your blaster variable. So that's good. Does it still compile? I'm not sure. Let's put a argument count character argument value. Let's put a main function here. Return 0. Let's see if we are still compiling. 2 warnings. Yeah, we don't use these. Yeah, that's fine. And 1 undefined symbol. Yeah, that's fine. That's just fine. So we need the reset DSP function, but we'll get to that in a minute. We're missing the IRQ. So we will do the same all over again. Temp less than string length of blaster, and then boop. Let's copy this. This takes too long otherwise. So now we are parsing the, oops, what did I press? Something. Let's parse this thing. So here we are looking for the IRQ, the interrupt. Then the SoundBlaster IRQ is the same, like above, but we can also have interrupts 11 and 12, for example. So if we look ahead by 2, and let's just hope we don't run out of the array at this point, but who cares? If this is not a space, then it must be another number. This is very, very cheap parsing. Actually, we could just use scanf, I think. That would probably be more safe. But just take the second number. Oops. Times 10. Actually, this, if we have 2 numbers, this must be a 1. So I'm not sure about this example code. But let's just go with it. It works reasonably well. So yeah, this whole part is pretty hacky. I think we should definitely rewrite this with scanf or scanf to parse. Whatever. And now we will return true if we actually, found something, which is, I think, not even necessary because, should be, that's even not necessary. If we are past this, we should have found something. And I didn't set the SoundBlaster base, right? Oh, okay, yeah, because there's a side effect. Side effect is probably not very nice, but this here will set SB base to a value if it found something at the address. Alright, and it will also have done a break, so we know that there must be something in there. So actually we could just return 1 here, otherwise we would have bailed out earlier. But let's go with this and program the reset function. So is it void? No, I think not. Should be int, because we return if we were successful. And it takes a port number, which is 16-bit. And the way this works, we write, and this is actually from the programming manual. And it says somewhere here, down the line, resetting the DSP. We write a 1 to the reset port, which is the 6th register, and wait for 3 microseconds, and then write a 0 to the reset port, and then we poll for the ready byte from the read data port. Sounds confusing? It isn't. So what we're actually doing is here, we output just a byte to the port that we are supposed to test, plus the reset register, and we write a 1. So what is the reset register? We just read that. Define SB reset as 6, 0x6. This is the register on the SoundBlaster card that's supposed to do the reset. So we are supposed to write a 1 and then a 0, but in between we are supposed to wait a few microseconds. So we delay for 10 whatevers. I think these are probably not microseconds, probably milliseconds, but doesn't hurt. And after this we also delay to make sure that the DSP settles in. And now we have to test if we were successful. How do we do that? Well, it says here we poll for ready byte 0AA hex from the read data port. That means we are reading in port 1 byte from the port plus, well, what is it called? The read data port. Read data. Let's call it status. And because you must check the read buffer status port to ensure there is data before reading the data port. And the read buffer status, if we scroll up a bit, is the port the register E. So we can already write here, define as the read data status as hex E, and this will give us an 80 hex if we are ready. So we also have to mask this because there might be some noise on there, I think. and we test if this is then equal to 80 hex. And I probably should put some more parentheses around there, just to make sure we are doing the right thing. So if this read data status says we are ready, then we can actually read out the read data register, and here it says that's read data is register A, so we'll put that here, read data, and this is supposed to read 0x0AA, right? That's what they said here. And if that's the case, then we actually know that this is a good port, and we return true. And otherwise, we can even skip that, we just say false. And there's a reset DSP, yeah, okay, got it. Because we did something wrong, right? Nope. I'm not quite sure what I did wrong. Can anybody tell me? Reset DSP. Reset DSP. Oh, look at this. Okay, forgot the semicolon, which makes the whole thing garbage. Success! Great. Now only a few missing things. We can actually already detect something, right? Let's try that. That's actually pretty good. So, how do we do that? Yeah. Detected. Just save this in a variable. SoundBlaster detected equals sp detect. If not sp detected, then we just print something. SoundBlaster not found. Something like that. Else, we know that we have something. SoundBlaster found at A something in hex, and then I something decimal, D something decimal, right? And what are the things? SB base, SB IRQ, and SB DMA. I think that's pretty nice, right? And here we can return error code or something. No, I don't believe you. Okay, this is better. If SB detected, yes, of course, this is an error. There are 2 warnings still, but that's fine. And now I can run it, and it was too quick. And it says SoundBlaster found at A220 I7 D1. You see, already you've got your first SoundBlaster programming. You successfully detected a SoundBlaster card. think that's pretty neat. And I also think this is probably enough for today. In the next episode we will set up the DMA buffer and the interrupt handler. And in the third part we will actually play something. As you can see, this is much more involved than, let's say, programming the VGA card with just switching to some graphic mode. However, I hope you already learned something. This will definitely be our most complicated stuff that we've done so far. I hope you liked it. If so, please leave a comment, hit the like button. If you haven't subscribed to my channel, please do. This does greatly help. And I hope to see you soon.